Hello. Algebra students, Mr. Lawrence here, and we are going to do a little review for our quiz. Shouldn't be too bad. All right, let's get right down to it. Most of the problems are going to take right off your review sheet. A couple of them I'm going to do a similar problem, so we're not doing the same exact thing. So problem number 2, I have to solve this system, and I have to tell if it's consistent, independent, consistent, independent, or inconsistent, right? And so let's see here. I think I'm going to do this one by elimination. Some of you are thinking, hey, substitution, because I could get x alone pretty easily, and that's not bad. I like elimination on this one because of the negative 4y and the negative 4y. If I just multiply this equation here by negative 1, and I multiply this equation by negative, or this side of the equation by negative 1, my first equation, of course, is still x minus 4y, and that equals 8. And then my second equation is negative 5x plus 4y equals 8. And then I'll combine. I'll add my two equations together. I'll get negative 4x. Those cancel, equals 16. Divide by negative 4. And I will get that x equals negative 4. Now I have to go back and solve for y, and I think I'll use this first equation. So I'll have negative 4 minus 4y equals 8. All I did was plug in to there. Okay, and so here I will add 4 to both sides. I'll get negative 4y equals 12. Divide by negative 4 on both sides. And I'll get y equals negative 3. There we go. That looks kind of like negative 3. So my solution is negative 4, negative 3. And so that is a consistent, independent system. It's consistent because there is a solution. It's independent because there's only one. All right. Problem number 4. I think I'm going to do this one by substitution, mainly because I did the last one by elimination, and partially because y is already alone. So I'm going to go 10x minus 5 times the quantity of 2x minus 6. That's going to equal 30. So I'm going to take this and I'm going to put it right there. So I'll get 10x minus 10x plus 30 equals 30. Be careful on your distribution here. It's a negative 5 that's being distributed. So negative 5 times 2x is negative 10x. Negative 5 times negative 6 is positive 30. These cancel, combining like terms, and I get 30 equals 30. Well, that's always true. Always true. If I could write always, always true. And therefore that makes it have infinite solutions. Okay? Infinite solutions. And since there is a solution, it's consistent. And since there's more than one, it's dependent. Remember, independent kind of means by itself or alone. And this solution, these solutions are not by themselves. All right, I call this problem 5.5a because it's like problems 5 and 6, only it's a little bit different in that I just made up a new problem for you. So let's see here. What I want you to do is I want you to find the parallel, a line parallel to this line, going through this point, and I want you to find the equation of a line perpendicular. Uh-oh, I feel a sneeze coming on. Hold on one second. Okay, the sneeze is gone, but be careful. Sometimes they travel in 2s or 3s, so we may have to pause again if that's the case, going through the same point. All right, so remember, the first thing I do is I find my slope of the original line. Well, that's negative of a over b, so that's negative 3 over 2. Then I find the parallel slope. Well, that's hard. It's negative 3 over 2. I need an x-coordinate, and that's going to be negative 24. I need a y-coordinate, and that's going to be positive 2. Even though the original equation is in standard form, I'm going to work from y equals mx plus b, slope-intercept form, and I'm going to plug things in. 2 is going to equal negative 3 over 2 times negative 24 over 1 plus b. And when I do this here, the 2 will go into 24 12 times. I'll have negative 3 times negative 12, which is positive 36 plus b. I'll subtract 36 from both sides, and I'll get negative 34 equals b. So now I know the slope and I know the y-intercept. I can write the equation. Y equals negative 3 over 2x minus 34. Okay, so let's see here. Hold on one second. Okay, so let's do the perpendicular one now. And let me see here. My perpendicular slope is going to be the negative reciprocal, and so that'll be 2 over 3. All right, the x-coordinate and y-coordinate did not change, and so I will set up my y equals mx plus b. I will go with 2 equals 2/3 times negative 24 over 1 plus b. That will go into negative 24 8 times, so I'll get 2 equals negative 16 plus b, and so b will end up equaling, well, I want to skip that step because some of you skip it and then you make a silly mistake, so I want to show it. Okay, so I'll get 18 equals b. So therefore my perpendicular equation is y equals 2/3 x plus 18. And there you go. All right, now I do want to talk briefly to you about the parallel and perpendicular equations. Okay, I'm going to give you a few equations. Hold on one second. Okay, I've got these 6 equations. I want you to pause the video on this and give me the equations of 6 lines that are parallel to these lines. Okay, when you're ready to see my solution, you go ahead and unpause the video and we'll see if our answers agree with each other. All right, so go ahead and pause the video if you haven't done so already. Okay, so here come my solutions. Now, x equals 2. You know, some of you don't know what kind of line that is. Well, remember I said to go ahead and graph it. So I'm going to get a little graph out here. Okay, and x equals 2 means that my x-coordinate is always 2. 2, 0, 2, 4, how about 2, negative 1? Okay, so if this is my origin, there's the x-axis, the y-axis, 2 zeros right here, 2, 4 is right there, I believe, and 2, negative 1 is right there. I'll get a vertical line, right? Going like this, and of course it'll be a solid line, and so let me make that solid. All right, so I'm gonna make that a little bit thinner. There we go. Okay, so I need a line of an equation parallel to it. Well, that'll be any line vertically going through the x-axis. And let me change the color of it. Okay. I'll make it pink. Well, maybe you can't see pink so well. There you go. You should be able to see that one. All right. So you could say x equals 1, 2, 3, 4, 5, 6. X equals 6 is one possible answer. All right. So x equals 6 would be a parallel equation. I'll do all my parallel equations in red. Okay. This one, all you need is the slope. The slope is 3x. So a parallel equation could be y equals 3x. Pick any number except negative 4. How about plus 2? There you go. It's a parallel equation. The slope on this one is going to be the negative of 4 over negative 5, which is 4/5. And so I could go y equals 4/5 x, and I'll pick a y, minus 3. There you go. They're parallel. Y equals 7. That's very similar to x equals 2, but let me see here. If y is 7, then I could have 0, 7 on the graph. I could have, oops, y is 7, so 2, 7 would be on the graph. And how about negative 5? 7. Well, let's see here. 0, 7, 1, 2, 3, 4, 5, 6, 7. 2, 7 would be right there, and negative 5, 7, 1, 2, 3, 4, 5 would be right there. I'm going to get a horizontal line, right? So let me draw that horizontal line in, and of course it will be a solid line. And so properties, okay, and we'll make it kind of a purple color. Now a parallel line to it would be to any line going through the y-axis that's horizontal, right? Can't seem to get that line to move. There we go. Let me change its color. Properties, oh, we'll make it, there you go, that light blue one. And let me put it there. So that equation would be y equals 5, I believe. 1, 2, 3, 4, 5. Yeah, that's right. Oops. Okay, so y equals 5 would be parallel. Okay, now the x-axis, well, that's just a horizontal line. And so what's true? Well, y is always 0. This is the equation, y equals 0. How do I know that? Because 2 zeros on the x-axis, 5 zeros on the x-axis, 10 zeros on the x-axis, and so that's the equation, y equals 0. Well, if I want a parallel, I could use y equals 5 again if I want. I could use y equals 7. I could use y equals negative 2. Y-axis is a vertical line, just like number 1. So I can use x equals 3, x equals 7, x equals 2, anything like that. All right, let's do perpendicular lines. Okay, and again, I'm just making up the y-intercepts on this. So let's do number 2 first. The perpendicular slope will be negative 1/3. So my equation will be y equals negative 1/3 x plus 2. Okay, the perpendicular slope here would be negative 5/4. So y is going to equal negative 5/4 x plus 1. I can just make up the y-intercept in this type of problem. Now these 1, 4, 5, and 6 are just the opposites. I don't know if you realize this. X equals 2 is a vertical line. Perpendicular line is a horizontal line. So y equals 5. The y-axis is x equals 0. X equals 3 is parallel to it. The perpendicular line is y equals 2. Could be any real number there. All right, except for, well, it's perpendicular, so it could be any number. The x-axis is the line y equals 0, so the perpendicular line would be x equals 5. And here y equals 7 is a horizontal line, so perpendicular would be x equals negative 3. All right, that's it for the video. If you've been staying up with stuff, I expect some pretty good results tomorrow. Mr. Lawrence signing off. Have a good night, everybody.